Why you need to read 1, 2, and more. What about this one? You can use free space. Most of the current modern DBMS system, including operating system also, they do not store the 100%. Usually 70 to 75% only. The other 20 to 25 to 30% will be leave as free space. So in Oracle, there is an option to specify PCT free option when you set up the DBMS system. Percent free. How much free space you will use? Like the 40% if you frequently update. The 20% if not frequently update. Okay? So in your the project B page 1, you need to determine. Okay? There's a PCT percent of the free space will be given. Only Word is 80%, right? I cannot remember exact percent. You will use only 80%, not 100%. So you can determine how many records for each. Okay, then the next topic of the file system structure is the RAID technology. I'm not going to explain details in the database system nowadays, which is not very popular. The only thing in the operating system also, but the operating system a little bit more detailed right here. But anyway, RAID means redundant array of inexpensive disk. How much is 1 terabyte? The hard disk drive nowadays. 1 terabyte? 1 terabyte. Yeah, price. 70? 60? 70? When I was database administrator, it's 1997. I think 1997 is around 20 years ago. Can you imagine how much for 36 gigabyte? 500,000 close. Yes. At that time, we purchased the EMC, the disk storage box. It's actually 72 gigabyte, but it's a mirrored. So available is 36 gigabyte. At that time, we paid 300,000 US dollars for 36 gigabyte. Very expensive, right? It was not that expensive at the time, actually. So it was one of the biggest the disk storage box. So not many people at that time used such a mirroring. So first, I'm going to give an example. This one is mirroring. Mirroring means when you insert the data, it will be copied exactly same as for Y. Y. Kind of backup. What if one of them is crash, like the scratch? Here you have another. So you have a time to recover, restore using this one also. You don't have to stop your business. Okay, that is mirroring. So that's good for such the reliability. Problem? Only 50% utilization. It was big issue long time ago when the hard disk drive was expensive. So another technique in the organizing the hard disk drive is so we have the A file, B file, C file, D file. This is a hard disk drive. So A, B, C, D. Instead of storing such a way, we divide into 4. So we put the A file A1, A2, A3, A4. This is code. Also B1, B2, B3, B4. Okay. This is called striping technique. Striping means you do not store the data on one hard disk drive, you segment and spread out. Benefit? You can process parallel. Right? So, for example, I'm running the finding prime number. This is the Java code run, the program. So for the A file, you can run here, run here, run here. You can increase the degree of parallelism. So you can do the parallel processing. So this is buffer. So this is called the mirroring. This is called the striping. What about combining these two? So mirror and stripe. So that is called 0 plus 1 technique. 0 means mirroring, and 1 is striping. So 0 plus 1 is used a lot in nowadays. Most of the enterprise level hard disk drive, they use both striping and mirroring. Even personal, the hard disk drive storage uses such a technique. That is enough for the RAID. Actually, RAID is the technology. Increase the utilization, and also redundant backup purpose. Because at the time hard disk drive was very expensive, we cannot use the mirroring 50%. How can we increase the utilization? We put actually 5. Then A1, A2, A3, A4, and one more thing is parity check. What is a parity check? Where did you hear the parity check? Network. You are the smartest student. So error detection. So network is not very reliable. Sometimes you lose the packet. But you can restore using such a parity check. Parity check is like a simple way. So always this parity number provide modular by 10, so 0, which means sum of this data should be 10, 20, 30. So let's say 10. So parity bit is in this case, the 4, because it should be 10. So even though we lose one of the data, we can restore. However, if you lose 2 of the data, you cannot. Okay, that is the parity. We can apply the same technique. So in this is called RAID 5 technique. Utilization, you have 5 and use 4 of them. It's 80%. However, even though you lose one of the data hard disk drive, you can restore. Unfortunately, if you lose 2 of them, you cannot. So at that time, it was a very popular technique to organize the RAID file. But at the time, the seller, the distributor, or manufacturer, they said there's no chance both of them at the same time fail. No, absolutely. So 0 plus 0.00001. But we got the 2 times of such a failure. Do you know why? Because most of the time they use the identical hard disk drive. They was born at the same time, same condition, may have a higher chance actually, fail the same time because of the temperature, moisture. Moisture is very, very important to manage the IT infrastructure. So may have the higher chance than you expect. So at the time, we lose the data, right? Actually, we restore using the backup data. That is a RAID. That's pretty much enough, okay, to understand. We are not using the box. I heard that still some of the small company, old company use such a RAID technology. Nowadays, only the 0 plus 1 mirroring, okay? So data striping and mirroring is used, okay? Mirror data, actually we have here, there is a mirror data. So mirror data. RAID 5 is this one. don't pay attention, just for your the knowledge, common sense, you can understand what is a RAID. Okay. Storage area network. We have so many family of the something area network. Local area network. What else? So, wireless, wide area network. What else? Personal area network, health area network, something area network. This is one of the storage area network, which means it depends. No, storage area network means when we purchased 20 years ago, when you purchase a very expensive hard disk drive, it's reliable because it provides something, the mirroring. Okay. Also, it has the 8 GB memory cache area in the storage. Okay. So, if we use such a very expensive drive for the only one computer, it's not acceptable for executive, the CEO or the top of the company. So we need to show all the computer can share this one. This very expensive hard disk drive. So we are going to implement something network based on the storage, which means all the computer can access this storage box like the local hard disk drive. How? You should have the very fast the network. So we can use fiber optics. So fiber channel, using the fiber optic channel, we can implement the storage area network. That is the SAN. Still, SAN is very popular in IT infrastructure. Okay? So just like this one, you have only SAN storage, only one hard disk drive, but it can be accessed by the different computer server. Also, one of the benefits of this one is you can dynamically change the quota, the usage of for each server. Well, how? For example, Web Advisor is very busy during the daytime, not nighttime. But nighttime, web server is busy. So why don't we allocate the different storage for them? So it's a dynamically change. We can get such a benefit. Another approach is the NAS. NAS consider each storage as a computer server. So when you access the data from this storage, you need to do the exactly same mechanism when you search the computer. How can you access this? Find the computer. You need to go to your router. Okay, router should have something DNS information. Otherwise, you need to go to the DNS server and find the root using the IP address. Exactly same thing. When you access the data using the network technology, so you can access data. Okay, different from the SAN is the connected, very high speed, the media. However, the NAS use such a local area network. Also, it can be routed. So there's a specific device to route. That is called a NAT. So you should have such a specific device to implement the NAS. This is just an example of the storage configuration. This is the box that I mentioned. So it's an EMC box. It's a 36 gigabyte at the time. We paid $300,000. So this is what I managed when I was the database administrator. It's a long time ago, so almost 15, 16 years ago. But still, it's a simple, similar configuration. So these are the database that I manage. Okay, it's just for your information. Okay, then next we
instead of rate, we don't really have to worry about it.
Yes.
Don't worry about it.
So as long as you know what is the rate. Rate is all the technology to organize the very expensive hard disk drive. Even though name is inexpensive, at that time it was very expensive. So increase utilization and keep the reliability. That is the rate technology. I don't know why it's keep asking. Oh yes, this one. But it doesn't show. Oh yes. Okay. Something weird. My device shows different one. Anyway, so we have learned about how to organize the file. File is the media, a data structure where our relational data will be stored. Okay, so we can create the file to store the table. So when the DBMS system, when a user submit a query like the create table employee with a column name, your DBMS software will call the file structure. It should be defined earlier by the programmer of the DBMS. We call the file, then insert the information about your column. Then will be created. So we can access the data using the binary search if that is ordered. Otherwise, we can use the brute force way. But it's still slow. So how can we address that problem? How can we speed up? There are different ways, right? Mostly we can use the
Primary.
cache area, buffer management, right? So we can speed up, okay? Another way is we can speed up the query using the query optimizer. The third one is, why don't we use a different structure, data structure that is indexing. So index is another data structure using the DBMS, okay? For what? For speeding up. At that time, we can most of the primary key use the indexing structure. However, if you take a look at the project B, page 1 and 2, it mentioned about the hash key primary key. Okay, please ignore any hash information in your project. Okay, we are not going to consider hash for the query optimizer. So today we are going the next class we will talk about the indexing. But keep your mind, index is another data structure. It's a different format. The file is like the record. Each record has a column, but index has a different data structure. Mostly we will learn about how the index is organized. We already discussed what is the basic structure of the index. It's a tree structure. Eventually we will learn such a tree structure to speed up the search. Okay. Last one, index. The most important remark when you understand index is when you take a look at index of your textbook. So it's not index. Give you a little bit of what is the index? Yes. So for example, foreign key, okay, close of create table, then comma what? Page number. 94. So any information in your index structure has keyword, comma, page number. So that is called the index entry. Index entry same. Field value. Field value means indexed value, comma, pointer, address, page number. So exactly the same structure as an index. That is an entry. So when we discuss about the indexing structure, instead of record, here each block, data block has the what? Record. But index structure will keep index key entry, field, comma, the value, comma, pointer. Okay, so even though I do not mention this block has the key entry, but you assume each index block keep the number of entry, index key entry that consists of the value and pointer. Any question?
I have a question.
Yes.
Can you just like explain what's the difference between a dense index and a sparse index?
Yes, that is the probably next here. Sparse and none.
Okay.
Yeah, sparse index means index key entry is the same as non-sparse means number of index key entry same as number of record data. Then sparse means the number of index key entry is less than data.
Okay.
Why?
Well,
Like the ordered file. For the ordered file, when we make the index for the ordered file, we have to index all of them. Not only anchor record, representative. If you know the representative, we can easily find the data in the same block. So that is dense index and non-dense index. Most of them nowadays is a dense index because it's not ordered. In case not ordered, no way. Okay, any other questions? So we will see, today is a Thursday or Tuesday? Tuesday, so we will see on Thursday. Neymar, do you have anything? Okay. The GA has some announcement.
For project B1, I will provide a sample output in the announcement later. Don't miss it. And for project A, so far three groups are missed to show me the demo. Obviously, it will be not 100% mark, but you have to let me know when you're available in the lab 1663 with your work, and you email me. I'm always available before your class, database, Tuesday and Thursday, before 1:30. You have to email me that I will be there before your work. So that's it pretty much. And for project B1, the due date will be not extended.